Right, so in a nutshell, 2.3, producing robust programs. In the first part, we'll go through 2.3.1. So what is defensive design? Well, the idea of defensive design is creating a program to anticipate any way that the end user could misuse the system. So you design the program to avoid that. Now, it doesn't mean that they're going to like try and hack it, but it could also mean that they could do something wrong, like type the wrong type of word into an integer or do something wrong. So you want to try and make it so the program doesn't crash, it behaves as intended, and that data is secure, right? So if any of these things happen, then defensive design has not been good enough. So if your program crashes, does the wrong thing, or data's uncompromised, has been compromised, then you've done a bad job. So how do we do that, right? Okay, so the first thing is try to predict how people do it. So for example, if you've got a login system, people may attempt to do a brute force attack on the program. Okay, so then you can say, for example, only allow a user to enter a password 3 times before it locks out. You could add a time delay between attempts. Even a few seconds would make a brute force attack pointless because it's got to take millions of tries. If you had a 2-second delay, that's going to ruin that right up. So, there's lots of things you can do to stop a brute force attack online or in a program. But yeah, so, here, for example, let's look at Twitter. People could spam a tweet out. Well, if the same person spams a tweet out 5 times, you could identify it and delete it. Now, I know Twitter still allows a lot of this, but that's their choice. But, there's various things that you could do to avoid misuse if you wanted to. Some of them don't, probably because they don't care about the misuse, or maybe they still make more money if the tweets get sent. But at the end of the day, if you wanted to, that's what you would do. So another thing is authentication. Okay, it's a way of authentication. It's a way of checking that they are who they say they are, and it can be as simple as a username and password, which is obviously stored against another username and password that is done, probably encrypted. And if they match, the user is authenticated. So, password is one way to check user authentication. Obviously, other ones, you've got key locks, which could be an app on your phone, sometimes called an authenticator. And then when you go to log into your bank, or like if I use my crypto exchange, it will text me a number, and it will ask me to enter from the authenticator a random number that's got some algorithm, and I've got to put in my password. So that's got 3-way entry. But then obviously it's money involved. But my bank will often do that. They might have if I try and log in on my computer from my Halifax, I have to okay it on the app as well. So that's another way. So yeah, I mean, there's many different types of ways of doing 2-factor authentication. Okay, so that means you're doing 2 ways to authenticate or even more. So another one obviously is biometric. This could involve the use of fingerprints or facial scans or eye scans to log in. A lot of mobile phones use this one. Some people don't like this as they fear private personal data is being interfered with, and there's privacy issues. But at the end of the day, I think most common people now have sort of got used to the fact that that's on a phone and that's what it's going to be. So when someone enters data in at any point, another thing you can do, I don't know why I've got these really badly all over the place. Maybe it was some deliberate thing. You can, I'll just leave it. You can validate the data. Now, it's not always possible to make it 100% correct. But you could check, say they got to enter in a certain thing, like, I don't know, a number between 1 and 100. You could check that it's in the right range, right? So like in the right range here. Check the value falls within a specific range. If they're supposed to be entering actual words, normal words, you could look them up in a dictionary, okay? If they're entering a date, you could check it's in the right format, or an email, for example, because email has to be something at something dot something, or various other dots, but it has to have an at in it, and it has to have a dot in it. And you can do a check for that. So you can know if someone writes at me.com, that's not an email address that's valid, because it can't be. You could just check that data's there at all. Like if the length is 0, get them to redo it. You can check too long, too short for passwords, etc. Have they written at least 100 words or 100 letters, depending on what you got them to write. And sometimes this is good. This is called a check code. So this happens in barcodes. So I'll do a very quick example. I'm not going to do a very good one. So I could say, right, so I'm scanning a barcode and I've got the numbers 5, 3, 6, 7, 3, 2. That will do. Right. So what you could do, when you scan things in a barcode, they often make mistakes, or they can make mistakes because they're scanning a barcode, real life stuff. So you add these up. So I've got 10 plus 11, that's 21, plus 5, 26. So put 2, 6. So now the computer can scan this in, check those two numbers are the total of these. Let me just recheck that. I've done that wrong. 3 and 3 is 6, 12, 19 plus 7 is 20. Yeah, so they could add that up, check that, and then they would know that this got scanned in or is very likely to be correct. Obviously, still chance it could be wrong because it could have scanned that wrong and that wrong, but most likely, if they add up to the last two, then it's correct. And that's called a check digit. It's used quite a lot, but yeah, that's that part. So lots of ways of checking input validation. If you're selecting, say, from like a postcode, you just could have a list of acceptable ones. Not postcode, sorry, county. There's only so many counties in the United Kingdom. You could literally list them, and if they type one in, you can check against the list or have a drop-down box or whatever. So now we're looking at maintaining code, okay? So when you're writing a program, it's very likely there'll be a team around it that's going to use that program as well, and they want to come back to it and use it properly. So one good thing, if a question comes up, how do you maintain a program? Well, you've got comments, so you can put comments in to help people know what you're supposed to be doing. So obviously, I could know what a comment is, but so using comments is a really good way to just get the online compiler up. Good way to let someone know what your program is supposed to do. Obviously, hello world's pretty obvious, but if I was doing some complicated calculation, I put a hash. This section works out the user valid data or whatever you're going to do in your thing, and it's just there for everyone to see in your project. So comments are a really good thing. Okay, good use of variable names or a naming convention. So what that means is that maybe all of your player stats will start with the word player. So there's and they maybe have all of they all start with a lowercase. And so there's a consistent naming convention. See, I do this. This is how I do my coding. Actually, I do this. Some people used to have a thing of putting like I for integers. So all integers began with I and all floats began with F and stuff like that. That can be okay. I think it's gone out of fashion, but it's up to you. When you go and work for a company, they tell you how to do it and you just follow on because that's what you got to do. Some people capitalize and do underscores. But what you don't do is do pH equals 100. Because then later on you're going to come back and think, what is that, acidic or alkali, what? And yes, you might say it's obvious now, but what you got to understand is you might come back to this program 4 months later and someone else might come back. You've really got to be strict. Good variable names, maybe a naming convention, everyone doing the same thing. Very important. All right, so the use of subprograms, okay? Basically, they just help to break down the program. They provide structure for the code. It's easier to understand if the code's all broken down to little parts. It's a lot easier to reuse the code if it's been broken down. You can reuse it. And it makes the program shorter because you've not got repetitive code. So using subprograms, procedures, functions are a really good way of helping maintainability. And last but not least, just indentation. Now, Python forces indentation anyway, because like that's literally how it knows about like being in a for loop. You have to indent, and if you're in an if, then you'll have to indent again. But not all programming languages force you to do that. So just making sure that everyone does indent is quite a good thing because you can line things up and say, right, I know all these things are part of this for loop. All these things here are part of the if. So I know by them lining up what they're part of, and that can be really handy. That's the main things for maintainability.